Welcome to another devlog for Reading Room, the VR app that augments book reading by matching the soundscape and environment to the content of the book that you are reading. So it's been well over a month since I've done a dev update. I apologize for that. It has been a busy month or so, done some vacation, but also I got really lost in doing OpenCV work trying to improve things. So where we last left off, we were able to grab still images from the headset, and we were having a bit of a garbage in, garbage out problem where those still images were lower quality, and so straight up OCRing them wasn't doing as well as I thought it would. So I ended up having to pretty quickly go down the route of installing OpenCV on C++ so we could get that running on the headset. We had already done some prototyping in Python, but it was necessary to start bringing that in. And we were trying to improve images by merging them. So taking multiple still frames from the headset and merging them. Last time in the last update, that was kind of a work in progress. It was sort of working, but not really. And then the last thing was I promised that in the next video we would go deep on OpenCV and everything that I had accomplished there. That video is still coming. That won't be this chat. For this chat, I think we may briefly look at some of the C++ and OpenCV code. But we'll look more at everything else that changed. So we'll do some things, we'll look at some of this code that's been updated, and then we will finish by showing a full demo of the app running on the headset, doing OCR, and we'll end the video that way. So I ended up having to refactor pretty much everything. We got rid of the old camera enhancer, so you'll notice camera enhancer.gd is gone. It used to be that in Godot, in GD script, we would do a loop where we would periodically grab a still image from the headset and then call down into C++ code to go do operations on it. That was starting to create some laggy issues where the app would freeze and do some other things. That was not desirable. So the end result ended up being to basically rip out any processing code like that on the Godot side, in the GD script side, and create a background process that would run forever. So now what we have is in our main setup function, we're still doing the XR initialization, but now we're setting up what we call a scanner service. And we tell that to start scanning, and we initialize that. And then on every tick of the engine, we call down to it to tell it to do some processing. One thing is that we are processing signals, so triggering a signal back up out of this background thread to the main Godot thread so that we can do things like, hey, there's available text, go display that in the app. So that's one thing that we are doing every time. And then the other piece being go and grab a new image and throw it onto our queue. And so that now allows for a very light layer of communication between this background C++ thread and the main Godot app that's running. And then in this main loop, basically we go and check after we initialize things, we get things set up. We then enter this main loop, and basically what we're doing is we're looking for new images off that buffer. We're then going and taking two frames that are side by side. We're actually trying to find two good frames, the ones that are most likely going to align. We align those, which actually works very, very well. Then we go do OCR. When that finishes, we trigger a signal, and then we come back and restart this loop over again. And so there's a pause version here as well as a debug version of it. But really it's this main else statement down here where we process available images. And then we kind of then sleep for a brief moment and then loop back around. So with that done, that means a lot of that processing code on the Godot side is just gone. Everything now is happening in a background thread in C++. So now all the business logic around the app, it just has to care about starting up the scanning service and then waiting for those signals to happen. So once I was going down the rabbit hole of doing lots of OpenCV work, I needed a way to test quicker. Deploying to the headset every time, holding up a book in front of the headset, was becoming quite tedious and unreliable. So I might have a good test case one moment, but not a great test case the next moment. And so it made it kind of hard to debug issues, and it made it slow. So I ended up going down the path of building out a full-blown test suite. So I have a lot of that in GDScript here. I looked into pre-made ones, like available test suites for Godot for doing unit tests or integration tests, and there are some that exist, but they weren't really doing all the things that I wanted them to do. So I built my own, and basically I've got I have a folder now of test cases, and I've given them different names for different scenarios. And you can see here on the side, we've got a test report. And you can say like this one scores pretty bad, 54, and that's because this test case is one where we can't actually merge frames. So actually, if we look at that one. So yeah, so if we look at that one, we'll see that the frames that I grabbed, I tried grabbing sequential frames, but I messed up, I made a mistake. And instead of throwing it away as a bad test case, I was like, well, let me keep that, because we end up grabbing just a single frame, and that's the frame we OCR. And so when we're unable to merge frames, we end up getting a score of about a 54. And that score is computing the distance from the known text for a given page to what we ended up OCRing. So doing computing a mathematical distance. But you can see there's this shaky leg one, which I thought was going to perform somewhat bad, because this is the good test here is one where I held the book as steadily as I possibly could. But I had a shaky leg test where it actually possibly because the two side-by-side frames had enough different data, but were still similar enough, that when we end up merging, we end up with a score above 90%. And this is taking less than 3 seconds to run for the entire page of text. And so if we look at that test scenario, you can see we're just grabbing 5 still frames off of the VR headset and throwing them into a folder. And so then we can then load that test suite, those test images. We can either run the tests individually, or we can run the entire test suite. If we actually run it individually, I'll do a -K flag here on, and we'll do crop. So we'll do that bad one and see how the bad one results. So with the test suite, I can rebuild the C++ code as part of the test suite running, or I can pass a -S flag to skip it. In this case, I'm skipping. Or actually, no, I'm not. Looks like we're building. All right, so now that that had a moment to run, the test is going to run through, and I can then go look at the logs. I can go investigate from there. And if we're running the entire test suite with all the test scenarios, we don't write any debug images out. We kind of keep things high level and fast. You can see the time here actually took a lot longer because there's a lot of overhead operations like writing images. So if I go look at the outputs for that, you can see we have a new output right now that just came out. Here's that test scenario. And then we can even spit out things like the Haka results in XML, so I can go investigate those. And so this has just really made it easy and super fast for me to go through and test things. I can then go look at other test scenarios that are working better. So if we look at that shaky one, we can see, yeah, we go through those steps, but things are a lot better, right? So we're finding good text, good clean cropping. We then find multiple frames that align well. And actually when we average them, averaging them actually removes some of the noise. So the act of averaging 2 frames together actually does some denoising. And then when we do some enhancing, as you can see, we got some pretty clean text here for that test scenario. And then some final enhancements before we send it off to OCR. So that's kind of the test suite. It took a while to build that out. On the Godot side, it's largely loading in a couple of things. So it loads in the images from that folder. So it goes to each of these based on the command that we pass in. So in this case, it was -K. If I did -S, we would skip the test suite. And then I can just give it a test name like the good test. And that'll call Godot from the command line to go run the full test suite. It'll pull in the images. It'll also load in this JSON document, which kind of details out how I expect the test to run, the test name, its score, how long it should take to run. So because I ran it individually, it took too long because we're writing out those images. So it failed because it was taking 8 seconds when I expected to take 4. And then on the Godot side, we do some parsing of those arguments. And then we go and find all the test scenarios that we want to run. And then we run them one by one. Run the next test, log the individual test results, if we have them, or like build them out as well, so we have that final test report. And then, there's a lot of other little steps we can do here that then allow us to do, the individual test report after each test, and then there's this final test report that I end up logging out. So that's the test suite. It's actually a decent amount of code, but it also means now this has its own scene. So we have our test suite scene, which just has a single node 3D with a script attached that we call from the command line. So actually, if I go look at that, so we have some argument parsing at the top here. If it's a specific test, we change our arguments based on what was passed in. If we're not skipping builds, then we run scons to build windows. And then the final thing is we have the Godot command where we call Godot headless, and we call this the test suite scene, which now means all this test code is completely separate from the running app. This code's never going to run on a VR headset because it's never referenced from main, it's not referenced from anywhere else. So this scene is sort of a dead scene that doesn't exist. It's only ever called from the command line. So going back to the main scene, as you saw in the opening demo, a lot of things have changed. So the hands I replaced and brought in some ones provided from Meta, which are now kind of match the ambiance of Meta a little bit better. We also got rid of that table, got rid of the book that's on the table, so I'm no longer doing a pickable object that you grab and pick up. Instead, I'm just sort of anchoring the book to, in this case, for the moment, the left hand. And then based on when we detect that there actually is a book in your hands and there's text to process, hiding and showing that book and making sure its alignment matches your hand. And then we do still have the debug HUD. I hit it for this demo right now, but that now has a project setting. So based on whether or not we are in debug mode, we'll determine when we call the setup HUD whether or not we show the debug HUD as well. Right now there is a standard HUD, which is going to include a little bit of lighting. It'll also include like a hide show ability for notifications to the user and other types of pop-ups that we might need. Based on whether or not the user triggers them or whether we need to give an alert to the user. And then beyond that, there isn't really too much that's changed on the Godot side. Now a lot of everything is happening under the hood in OpenCV. I have now gotten it to the point where we are OCRing text. The time from when we capture an image to when we display the OCR text in the app is now 8 seconds. And I'm pretty confident I can get that down to below 5 seconds. Now that's just to get the first 2 or 3 lines of text to show up. Once the user then starts reading, then we can lazily start pulling in the next couple lines and then a few lines after that, and then slowly build out that page as they're reading. So with that, let's go take a look at the final demo and see it all kind of coming together. All right, so here we are back in the app. If I open a book now and I hold it steady, we'll start OCRing. After a couple of seconds, we will transition into the VR app. Now it's detecting the first couple of lines of text, which, again, the quality is really bad at the moment. I think I know what I need to do to fix that, but there's a couple of bugs happening in the back end. But we've now transitioned into a VR experience instead of being in the AR pass-through mode. And as I continue to hold the book here, well, if I hold it steady enough, we'll get some better text in a moment. Okay, so here we are. We got some little bit better text. And then if I turn and put the book down, we leave the experience. If you'd like to follow the project more closely, I stream at least twice per week to both Twitch and YouTube, where you can see me get deeper into the technical problems that I'm solving as I'm solving them. And I'll see you in the next one.